Hello everyone. So in the previous video we talked about the basic gates implementations using NAND gate. So now we'll discuss about the basic gates implementations using NOR gate, and the things are left us like XOR and XNOR gate implementation. This is a special case, so that we'll just discuss about in the different video. So now we'll just implement the basic gates using the NOR gate. Okay, so first we'll start with the basic NOT gate. So as we know, right, so the same procedure will follow. A B and A plus B, the whole bar will be our truth table of that, and here we'll be having only one input, so A and A bar. So we'll write this truth table. To write the truth table, how to write the truth table, you just come to know from the previous videos. I'll provide the link of those, so please go ahead look at those. You will get understanding on how to write the truth table and how to find the functionality of those things. Okay, so you don't need to mug up all the things. You just need to understand that how the AND gate will work and OR gate will work, so you can write the truth table of those. Okay, so we'll come here. So this is the truth table of that one NOR gate. As we know, if any one of the as I already wrote now, right, so other than this one, all places we all will, yes, if any OR gate is a thing will be like if any one of the input is high, means it will be leaving the output as high, but the NOR gate is just an invert of that one, that just an inversion of that one. So you will be like all the bits are 0 means only you will be getting the output as high, or otherwise you will be getting the output as 0. This is what the truth table of the NOR gate. Okay, so same as that one. So what we have now, we have this one, A plus B, the whole bar. So this is the gate or circuit or cell we are having. Currently we have only the NOR gate cell. NOR gate library only we have. We don't have any other cells. So any functionality you want, you have to implement using only the available gates only, right? So the NOR gate is the only available one. So how we can, from the truth table the same as like that. Okay, so if you look at the inputs here, because we will be having only one input for NOT gate, for NOR gates you will be having two inputs. So if you see, if both the inputs are same, like how we will make that as same, we'll just short that one. Okay, so if you just short that one, if you see the truth table, what we are getting, if the inputs are same, only one input we are getting from the external, right? Only 0 we are getting from the external, and the output will be the inverted version of that one. Only 1 we are getting from the external, and we are getting the output as 0. So simple as that. We can just connect only, this is two inputs, so we can just short that and give only one input at here, and here we will be having, generally what we will be having, A plus B, the whole bar. So here A is B, A and B both are same, so A plus A the whole bar will be the output. So here if both are same means, okay, you see generally our operator what will do, 0 0 means it will give 0, 1 means it will give 1. So if both are equal, it will be a single A only, so A bar will be the output. So if you short the inputs of the NOR gate, and the output you will be getting the inverted version of the same input what we are giving at the input. Okay, so next, this is the basic NOT gate we have implemented using our NOR gates. Okay, so this is what this is one of the method, because if you see, we are just giving the first we are just using the first and last column row of the truth table to implement this particular NOT functionality. So currently we have some other technique also, how we will be like, generally what you know, OR gate you take. Okay, OR gate functionality, if any, if you simply see anything, if you just ANDed with 1 means the output what it will become. If you see, okay, not OR gate, I'll explain something. If A is 1, okay, we know that A is always 1. So that time, if anything we are adding is 1 means what the output will be always 1. It won't be depends on any of the input, because we already what we have discussed, the OR gate is like, if any one of the input is 1, output will be 1. It won't even look at the second input. If the one input is 1, it will make output as high. It won't be dependent upon the second input. Okay, so okay, another one scenario we'll look into. If A is 0, okay, A is 0, the next output will be like, okay, one input is 0 and another input it could be 0 or 1. So the output will be always depends upon the output will be, here it's output, so here output will be always the B. If it is 0, it will be 0. It will be, if it is 1, it is a 1. So any one of the input is 0 means it won't play any role at the OR gate. Since it's 0, OR gate we know, right? We need a high to make output high. So it depends upon the another input. If another input is 0, it will give output as 0. If another input is 1, it will give output as 1. So this is what generally the OR gate operation. Okay. Why I am talking about this one now? So we have same NOR gate, right? So if you look at these two combinations, okay, of the truth table, if this is 0, okay, NOR gate we already know, it's just an inverted version of the OR gate. So here also one input is 0, the output is like, if you see, if you clearly look at this one, it will be the inverted version of the another one input. So the output will be the B bar if A is 0. So one more technique to connect that is, if you give this as to ground or 0 or low, the output will be the inverted version of the input. Okay. So these are the two type of implementation of NOT gate using NOR gates. So here, one thing is both inputs we just shorted and give a and the output will be getting the A bar, and the another one method is just we are making it as ground and making another input is giving another input as A to make a output as A. These are the two type of implementations of NOT gate using NOR gates. Okay, I think this is clear now. Same as NAND gate only. So there will be having different kind of thing. If you remember that we will connect this one to VDD, because the AND gate operation is that, like, if the one of the output is 0, it will make output as, we'll talk about that also. Now you will get clear idea why these both are like this. So if we go for AND gate, if one of the input is 0 this time, that time it is one of the input is 1, the output is not at all even looking at the second input. Here also, if the input, one of the input is 0, the output will be the 0. So 0 into 0, 0 into anything will be the 0, right? So the output it will make as 0. If one of the input is 1, the output will be B. That means another input it will follow. This is because the AND gate operation is just like a multiplication. So 1 into anything, that anything, 0 into anything is 0. This is what the AND operation. Okay, so that's why there we have like this one. Both the inputs will just short. That is same because it is like OR AND operation, that, right? So both OR AND operate, it will be like A into A also. I'll explain some of the properties also. It will help you. A into A plus A, both are A. It won't be anything. So the shorting of these things will be same. And here it will be high VDD we have connected to make the NAND gate as this one. So this is what the NOT gate implementation using these gates. Okay, this is clear, right? So we'll just go to the this one and all, it will be easy only. OR gate now. So OR gate, as we know, okay, first we'll write these things. We are writing, this is the truth table of both of them. That, okay, 0 0 means we will be getting this one as 1, others are 0 for this one. For here it will be just on this one. Now it is clear that we no need to look at anything. If you see this one, the output of these things, it is just an inverted version of that one. So what we have now, we have the NOR gate as in our library. We have only NOT gate. So the output of the we have only the NOR gate. So if we just invert our output of the NOR gate, we will be getting the OR gate. Okay, so AB, it will be the A plus B the whole bar here, and we'll just invert means this one. So we already know how we will make our NOT gate using NOR gate. Okay, how we know, that one we already discussed. So we have to just short our inputs of the input terminal. So if we give here, so A plus B the whole bar will be here and A plus B will be here. Okay, this is as simple as that. Since we have to add the inverter at the output side, because from the truth table we come to know the NOR gate will be the OR gate will be the inverted version of the NOR gate. We can just add the output of the inverter at the output of the NOR gate to make the OR gate. So simple as that we did. Okay. Yes, I think you are clear from here, because this is just an inverted version of the output, right? Yeah, that is okay. Now we'll just go to AND gate. Okay, this is just something different. Yeah, this carefully you listen. We have something to discuss here, right? So what we have this, we have to implement this AB, and what we have is A plus B the whole bar. As we already know, we have to fill up the truth table of both of them. So here you will be seeing like this. So okay, now if you see there is no direct relation between these outputs, right? So like simply if we look at the same input, if you are giving 0 will be 1 here, but here it is 0, so here also 0, here only the inverted version. So you can't even add just simply add the inverter at the output will not make this as an AND gate. You have to think about something. If you clearly see your input, these two things, if you see this one is coming here, this 0 is coming here, this 0 is coming here, and this 0 is coming here. Just truth table is getting inverted. It's like that. Yeah, it's getting reversed in the output side, but it's not an direct inversion at the output. But what we can do, currently now it is coming, how it's coming now, if our input is 0 0, this output 1 is outputting, it is giving the 1, but we need 0, that means this 0 we need. If this is 0 1, it is giving this 0, but we need this 0. Okay, we need this one. And if it is this one, it is giving this, but we need this. If it this one, if our input is this, it is giving this, but we need this, okay. So it's, if you see, just the outputs are it's like reversible. If you reverse this one, okay, if it is okay, consider okay, currently we have this, right? It is getting, okay, this is my AB. So what it is giving output 1 0 0 0 0. What I need 0 0 0 1. I need the 0 for my AB as 0 0. Okay, but my circuit, this one NOR gate, what it is giving me is not that. It is giving me this one. I don't need that, but this particular one is giving me my thing. There the inputs will be 1 1. Here it will be 1 0, it is 0 1. So for 1 1 it is giving my expected input, and 1 0 it is giving my expected, 1 0 1 it is giving my expected, and 0 0 it is giving my expected. What I am trying to tell here, I need an inverted version of that one to make my, see, this is an A bar B bar. Okay, consider this is my A bar B bar. I am giving my input as 0 0 0 only, but for my NOR gates, if I give as 0 0, okay, what I will be getting 1, but I don't need my one, that one there, that I need this one. So if I okay, so here if you see, if I simply invert my input, okay, so 1 1 1 0 0 1 0 0, if I just invert these things, then I will be my, here it will be my A bar B bar. Only this A bar B bar only, if I give to my NOR gate, what it will give, if it is 1 1, what is the NOR gate will give 0, so it will give 0 here. If it is 1 0, it will give 0. If it is 0 1, it will give 0. If it is 0 0, it will give 1. So this is the, okay, if I give this as an input, my A bar plus B bar the whole bar, that means the NOR gate of that will give this one. Okay, A bar B bar, that NOR gate will give this my output. So this will resemble the same as AB. So this is what I expected, right? So here our AB is 0 0 0 1 1 0 1 1. This is the combination we are giving, but our A bar B bar will be this one, and this is going to the NOR gate, and it will give the output as, it will give the our expected output. So here it will be A bar B bar, and this already we know A bar will be this one and B bar will be this one, only if we short our inputs. Okay, so this is what the implementation of the AND gate using NOR gate. Same as that, only inversion should be happening at the input side rather the output. Okay, so it will give the output. So simple as that. Just by looking at the truth table, we could implement those things. Okay. Yeah, this is what about the those basic gates implementation of using NOR gate. Okay, so we have covered these things here. Then XNOR and XNOR and XNOR both will just discuss in the next video. Clearly about both using the both NOR and NAND gates. We'll discuss. These are all about the basic gate implementation using NAND gate. Thank you for watching.